Okay. So in the last class we discussed about work and energy. Today we are going to discuss about different forms of energy. Okay. I know that you are familiar with this kind of energy more or less. Okay. At first we have mechanical energy. Okay. Mechanical energy can further be divided into kinetic and potential energy. We will study in details about this. Okay. In this SSA level, we are going to study this mechanical energy in details, and we will just go through, I will give you a short review on rest of the types of energy. Heat energy, from fire we are getting heat energy, right? Or whenever we are rubbing our hands against each other, heat energy is produced, right? Then sound energy, I am talking, you can hear me, this is sound energy. Light energy, from the sun, from the bulb, the light energy is coming. Magnetic energy, yes, between two magnets there is attraction and repulsion force, right? If you bring closer north pole to another south pole, then what will happen? They will attract. And if you bring closer north pole and north pole, they will repel each other. So there is some kind of force, right? So this is magnetic force. Then we have electrical energy. Electrical energy is using electrical energy. Actually, we can run our appliances, fridge, TV, AC, whatever we are using that requires an electrical connection is using an electrical energy. And then we have chemical energy. Chemical energy, petrol. We can consider petrol. See, petrol we are putting into our car, and the car is running. When the petrol is over, the car cannot run. So definitely the petrol is having some kind of energy, right? Which the car is utilizing to run. So this kind, the energy that is there in petrol is chemical energy. Okay, and then we have nuclear energy. I know you have heard about nuclear bombs, right? Large amount of energy is produced when a nuclear bomb is exploded. So definitely there is some kind of energy within the nucleus, right? So using that energy, we can produce the nuclear bombs. Okay, this is some higher level thing. Okay, in nuclear energy, if you study physics in university level, then you'll get to know about this more. Okay. Then we have solar energy. You know about this, right? Okay. Nowadays, many houses are using this solar energy. There are solar panels on the top of the roof, right? Using the light and heat energy that is coming from the sun, we are producing electricity, right? So this energy that is coming from the sun, we can say that that is solar energy, and we are utilizing that to produce electrical energy. So these are some kinds of energy. Some other kinds of energy are also there. Okay. So in this level, as I said already, we are going to focus on mechanical energy. Okay. So mechanical energy can further be divided into two categories, that is kinetic energy and potential energy. Okay. As you can see, I have already written the definition of kinetic energy. The kinetic energy says that the energy that develops due to motion of a body is called kinetic energy. From the definition itself, it is a little bit harder to understand. That is why I would like to tell you to open your book and come to page number 102. Open your book and come to page number 102. At the bottom of the page, you will see that there is a topic kinetic energy. Okay. So we are going to read this paragraph. Okay. I will give you 5 or 10 seconds. Oh, already I can see Abdullah has raised hand. Abdullah.
Sir, what is the profit of using solar energy or solar panel in home?
Okay, in remote areas in Bangladesh, in remote areas where there is still the electrical connection has not reached. Okay, so there people can use this solar energy. Okay, you do not need an electrical connection to if you have the solar panel on the roof. Okay, the advantage of having this one, okay, without any electrical connection in your village, you can produce electricity from this solar energy. Okay. And can you tell me a disadvantage of this solar energy? Let us say in a house there are solar panel and they only use the solar energy. So what will happen?
Sir, in night time it won't work.
Actually, yes, this is one thing. In night time, it will be a little bit of problem because in night there is no sun. But in the solar panel, there are such arrangement, they can store the energy so that it can be used during the night time. Actually, the problem will be on a rainy day. Okay, on a rainy day when the sun does not come up, or in severe winter season when you cannot see the sun, until 2 o'clock. So that time it is a problem. The solar panel does not get any sunlight, and as a result, it cannot produce any electrical energy, right? So this is one disadvantage of using solar energy. But
Sir,
you know,
solar energy produces electric energy.
yes, solar energy we can convert it into electrical energy using the solar panel. If you know Google it or search it in YouTube, there will be so many videos that will be showing you the process. Okay, which will
Okay.
show you the process of how solar energy is converted into electrical energy. Anything else, Abdullah?
No.
Okay, then I will listen to Fatima. Yes, Fatima.
Sir, mechanical energy arekbar bujhan.
Mechanical energy actually we will understand through these two. Okay, kinetic energy and potential energy. Or I can put it in general sense. See, my hand, this is like a machine, right? Okay, with my hand I can apply some force on a body and do some work, right? See, I will lift the duster, I have done some work, I have applied some force on this one, and I have gave it some displacement, so I did some work. As I did some work, definitely I have spent some energy. Yesterday we discussed about this, right? If you are doing some work, you are expending some energy. And if you do 20 joule of work, you have spent 20 joule of energy. Okay. So here the energy that I'm spending is mechanical energy. Okay. This is some general idea. Okay. Now, further we will learn about this kinetic and potential energy. Okay. I hope anything else you want to say? No, I guess. Okay, so we can move on with kinetic energy. Come to page number 102. This kinetic energy topic, we are going to study this one. We have discussed earlier that the ability to do work is energy. Yes, anything that has the ability to do work, that one has some energy. Clear this one? Okay. Every one of us knows that when an object is in motion, it can push another object and set it into motion, resulting in the object moving a certain distance due to pushing. Yes, when we can think of an example like a truck is in motion, right? Suppose on its way it collided with a car. What will happen? Now, even though the car was static, the car was at rest, due to the application of force by the truck on the car also will slide a little bit with the truck, correct or not? So here we can see that the truck is applying some force on the car and causing some displacement. According to physics, we can say that the truck has done some work. So if the truck has done some work, definitely truck has some energy. What type of energy does it have? This is kinetic energy. Now, the truck could do the work because it was in motion, right? If the truck was not in motion, then would it be able to do any work? No. So that is why when the truck is in motion and it can apply some force on somebody and it can cause some displacement due to the application of that force, that means it can do some work. And whenever a body can do some work, we can say that it has some energy, and the energy that it has due to the motion is called kinetic energy. This is what we are discussing here, kinetic energy. The energy that develops due to the motion, this is the most important word of this definition. The energy that develops due to the motion of a body is called kinetic energy. If there is no motion in a body, then there is no kinetic energy. Simple. Okay? The energy that develops due to motion of a body is called kinetic energy. And we express this one as Ek. E we express for energy and K is kinetic energy. So Ek. K we will write in subscript. Okay? And as it is an energy, the unit will be joule and the dimension will be the dimension of energy. So let us go through the paragraph, okay, so that we can get a clearer idea. This kinetic energy paragraph, okay. So we already read this one, that every one of us knows that the second line I'm studying, reading, okay. Every one of us knows that when an object is in motion, it can push another object and set it into motion, resulting in the object moving a certain distance due to the pushing. You can understand and you can find the similarity with the example that I gave, right? Okay, so making another object move means definitely a force has been applied there. Okay, without force, object will not move. This is inertia, right? If you do not apply a force, the static body will remain static, it happens due to inertia, right? Okay, making another object move means definitely a force has been applied there, and traversing a distance. Traversing means covering or traveling. Traveling a distance due to this force means work is done here. Force is there, displacement is there, work is there. Okay, therefore we can say firmly that the energy that develops due to motion in a body is certainly one kind of energy or kinetic energy. Okay, so in the previous chapter we said that the terrible road accidents that happen and the losses that occur are mainly due to kinetic energy. See, we already solved some problems related to conservation law of momentum, and in the some problems are like this: the truck was going and suddenly the driver lost its control and it hit a static car and both of them slided together. Terrible accident, right? So this is happening due to the kinetic energy. Okay, when a bus or truck or car moves at high speed, then it has a high amount of kinetic energy. The more the velocity of an object, the more the kinetic energy it has. Okay, the more energy, the more velocity, the more fast you will move. Okay, now we will. I would like to show you some calculation. Okay, let us say I know that the body is moving and I know that it has some kinetic energy, but how much? How much kinetic energy does it have? I want to be able to calculate this one. So I will show you the calculation now. Okay, and I hope that you have already finished writing. If anybody didn't yet finish writing, kindly raise your hand. Anyway, I can provide you the recording later, so you can take notes later also. Okay, so I'm going to erase this one so that we can utilize the class time as much as possible. Okay, now we know that. See, we will study from here. Let an object, page number 103. Let an object of mass m. We are studying from this line. Kindly go through this one. Let an object of mass m be displaced by an amount s due to the application of force F. That means we have a body of mass m. A force is being applied on this one F, and as a result of this one, it is having a displacement. It was previously here, now the body has come here, so the displacement is s. Okay, this is also so this is the initial position, initial. Okay, and due to the application of force, the displacement occurred, so this is the final position, and the distance between initial and final is the displacement. Okay, so the work done, W by the force. So if I want to find out the work done, I know from the definition of work, W is equal to force into displacement, right? Now, if you remember, F equal to ma from Newton's second law, we know this one. F equal to ma, right? Anybody would like to disagree? No, I guess. Okay. Now, for Newton, there are four equations of motion, right? We studied. If you remember, the fourth one is v square is equal to u square plus 2as, right? Now, as we are considering the initial velocity was 0, that means the body was at rest, it was not moving. Due to the application of force, it is now in motion, right? Then it will have a velocity. Okay, so the v is the final velocity, u is the initial velocity, which is 0, okay, because the body was at rest. A is the acceleration. Whenever there is some force, there will be acceleration and there will be change of velocity. We already discussed about this so many times in the previous two chapters, right? In motion and force. Whenever there is force, there is acceleration, and whenever there is acceleration, there is change of velocity. Please remember this thing. Okay, three things. Whenever there is force, there will be acceleration, there will be change of velocity. Okay, so as we are applying some force, there will be change of velocity and it will result in acceleration, which is a, and s is the displacement. So here you can see that I have as here, right? So from here I will try to find out the value of as and replace it. Okay, so u, this one will become 0 because the initial velocity is 0. So v square will be equal to 2as, or I can write 2as equal to v square, then as will be equal to v square divided by 2, correct or not? So if I let us say this equation I have taken to be equation 1, this equation. So replacing the value of AS in equation 1. What we will get? W is equal to M into AS is V square divided by 2. So W is equal to half M V square. And we already said that the work done is equal to the energy. And here the energy is kinetic energy. So in case of W, we can write EK. I'm saying again, work is equal to energy, and here the energy is kinetic energy. That is why I'm writing EK. So EK is equal to half mv square. This is the equation. Okay, to calculate kinetic energy, you have to keep it in your mind, because while solving the numerical examples, we will be using this equation several times. Okay, so please keep it in your mind. Okay, I will put some star on it, so that you understand the importance of this equation. Okay, we will learn mainly two equations. One is for kinetic energy, another one, if you remember, another type of mechanical energy, that is for potential energy. Oh, Mahmoud raised his hand. Okay, Mahmoud, what is your doubt?
Sir, I didn't understand this one. W equal Fs.
Which one?
The first one, W equal Fs.
W equal to Fs. Work. From the definition of work, we know that the work is equal to force and displacement. See, the product of force and displacement is work. So F into S. Okay, the product of force and displacement. Did you attend the last class? Did you attend the last class, Mahmoud?
Yes.
So in the last class, we discussed about the definition of work, right? In the definition of work, I said that the product of force and displacement is work. So F into S, now F is equal to MA, S is there, so MAS, and we are trying to find out the value of AS. We will use this equation, V square equal to U square plus 2AS. From here, I am finding out the value of AS as V square by 2. I will replace this value in the equation 1. This is equation 1. So if I replace the value, it will become M. AS will be replaced by V square by 2. So it will be half, it will come forward, and M into V square will be there. And I already said that the work is equal to energy. And now in this case, the energy is kinetic energy, right? Because the body is moving. So this kinetic energy will be equal to half mv square. So if you want to calculate the kinetic energy of a body, then you must know two quantity: mass of the body, the velocity of the body. If you replace the two values, then you can easily find out the kinetic energy. Any doubt, Mahmoud?
No.
Okay, GM.
Sir, can you kindly explain the third line? V square equal to U square plus 2AS. Why you put an arrow on that U square?
Because initial velocity is 0 here. I said that the body was at rest, and then we applied some force, it came into some motion, it gained some velocity. So if the initial velocity is 0, U is 0, then U square will also be 0.
Yes.
Okay, actually, okay, I will not put an arrow. We can just consider this one as 0 on C. U square. Okay, so in the next line, if I replace the value, V square will be 0 square plus 2AS. Now 0 square is 0, so we will remove the 0 here. So V square equal to 2AS. We can write this. Okay. Clear, GM?
Yes. Yes, sir.
Okay. Yes, Fatima.
So why you use this formula?
Huh?
A formula can you use question?
Con formula?
V
V
square.
square equal to U square plus 2AS.
Yeah.
Because in other equation you do not have AS. I will write the full equation for you. V equal to U plus AT, S equal to U plus V divided by 2 into T, and S equal to UT plus half AT square, and V square is equal to U square plus 2AS. I need to find the value of AS. Can you see any other AS other than this one? Any other AS is there?
No.
No. That is why we will use this equation. Okay. Now, Robin.
Sir, in sir, W you write E energy, okay, but why you write K? kinetic energy. They're same.
Yes, E is energy. Now EK means kinetic energy. Here the body is in motion, right? So we know that what kind of energy it has. Kinetic energy. Because it is in motion, so I express it as EK. I already showed you the symbol of kinetic energy is EK, right? And the symbol of
Yeah.
potential energy will be EP.
Okay.
Okay. So we are clear with the calculation of this one. Okay. Okay. I hope everybody took note, and those who didn't,
Yes,
you can
finished.
write it later from the recording itself. Okay. Now, in this case, we considered that the body was at rest. It was at rest, it was static. That means the initial velocity is 0. Now, what if the body was not static? That means the body was not at rest. The initial velocity was not 0. Then how the equation will look like? Okay. See, we will see that. Now, so we know that v square equal to u square plus 2as. Okay, now u we cannot consider 0. Okay, I will give you an example. Take the incident of truck and car. Okay, we consider the car was static and the truck was in motion and it hit the car. What if the car was also in motion and the truck came from behind and hit the car? That can be one possible scenario, right? So we will discuss how the equation will be if both the body were in motion. Okay. Now, if I multiply half m on both the side, then what will happen? Both sides I have multiplied v square, I have multiplied half m, and here I have multiplied half m. So what will happen? Half m v square is equal to half m will be multiplied with u square plus half m into 2as. It will be multiplied with 2as also. So half m v square will be equal to half m u square plus 2 and 2. They will cancel each other and it will become mas. Then half m v square is equal to half mu square plus, now ma, this is f, right? Ma, this is f equal to ma, f into s. So half m v square is equal to half mu square plus f into s, force into displacement. This is work, right or wrong? So from here I can write half m v square is equal to half mu square plus ek. Now work done is kinetic energy here, right? We already saw this one. Is my writing clear? Because I think the marker, the ink of marker is getting faded. So if you face any difficulty in understanding in any line, kindly let me know. Fatima, Acha Fatima, let me finish writing, then I will come back to you. Okay, I can see you raised your hand. Okay. So from here, what I can write is, I want to find out the value of ek, right? So I will just change the side of this one, half mu square, it will come this side. It will become half m v square minus half mu square is equal to ek. So ek is equal to half m v square minus half mu square. Now, as it is final velocity, I can say this is final kinetic energy, Ke, final kinetic energy, minus initial kinetic energy. Initial kinetic energy. Now, see, the previous case was the body was not in motion. Okay, this body was not in motion, the initial velocity was 0. Now, if there is no velocity, there is no motion, no kinetic energy, right? I will say again, kinetic energy is developed when the body is in motion. If the body is not in motion, then there will not be any kinetic energy. So as initially the body was not moving in the previous case, okay, the body was not moving. So as a result, there won't be any kinetic energy in this one. That is why there was no initial kinetic energy in the previous one. But here, now in this case, we are considering this body is not static. It is having some kind of motion, right? It is in motion, so it is having some velocity. If it is having some velocity, then there will be some initial kinetic energy, right? Okay. So this is initial kinetic energy because this is initial velocity and this is final velocity. This is final kinetic energy. Okay. Now, Fatima, yes. What is your doubt?
Sir, I didn't understand from first.
From first means this one.
হ্যাঁ একদম শুরু থেকে
Okay, no problem. V square equal to u square plus 2s. This one we know from the equation of motion, right?
yes
Okay. Then on both sides, I have multiplied this part. Okay. See, the half m. This part I have multiplied on both the sides. I can do that, right? If I want to balance on both sides, I have to multiply the same thing on both sides. So half m, I have multiplied. See, v square is v square, u square plus 2s is there. I have just multiplied half m, balancing, right? Then what will happen? Half m v square and half m will be multiplied with u square first, so it will become half m u square when the bracket is raised. Okay. Then half m, it will be multiplied with this one also, half m into 2as. Okay. So here 2 and 2 they will cancel each other. M into as will become mas. Okay. The rest of the part is same. Half mv square, half mu square, they are same. This is becoming mas. mas. Now ma, this one can be written as f because f is equal to ma. From Newton's second law we know this one. So force into displacement, this gives me the work, right? And work is equal to energy. In this case, the energy is kinetic energy, so I write Ek. Now I want to find out the value of Ek. So what I will do, I will separate this one. If I change the side of this, then what will happen? I can find the value of Ek. So this is what I did here, okay? Half mv square on the right, it was on the right side, now I bring it on the left side, so it will become minus. So half mv square minus half mu square. This is final velocity, so this energy is final kinetic energy. This is initial velocity, so this is initial kinetic energy. So this is the next equation that you need to keep in your mind. Okay. So reading the question, you have to understand that whether the body was static or the body was in motion. If the body was static, then you have to use the previous equation, that is Ek is equal to half mv square. But if the body is already in motion, then you have to use this equation to calculate the kinetic energy of the body. Fatima, you want to say something else?
no
Okay. GM, yes.
Sir, I want to know that is the equation half mv square minus half mu square?
Yes, half mv square minus half mu square. It is not clear.
Why is it like half?
Huh?
Why is it half?
It is already there in this equation, right? And if I want to see, this is final kinetic energy. Kinetic energy equation is half mass into velocity square, right?
Yes.
It is already there in the equation.
Okay.
Okay. So what I will do now, we have less than 10 minutes left. Yes. Who?
স্যার আমি
Nazmul.
এই লাস্টের 3 লাইনটা একটু বুঝিনি, একটু বুঝে দিবেন আরেকবার?
Which 3 line?
লাস্ট 3.
Is this 3 line?
Yes.
Or this side?
No, that side.
Okay.
Yes.
See, I want to find the value of Ek. So
Yes.
I will change the side of half mu square. If I change the side and bring it to the left side, then it is plus here. If I change the side, it will become minus half mv square minus half mu square is equal to Ek. Now what I wrote is, I just change the side Ek, okay, and half mv minus half mu square. It is like if x is equal to y, I can write y is equal to x. It is the same thing, right? So this one is equal to
Yes.
Ek. So I wrote Ek is equal to half mv square minus half mu square. Now this is the final velocity, right? V, final velocity. So this is final kinetic energy. This is initial velocity. That is why this is initial kinetic energy. Final kinetic energy minus initial kinetic energy.
Okay.
Sir,
Bolo.
Sir, in the EK and KE is same.
Yes.
You wrote in the last line.
Yes, yes. EK and K is same. Kinetic energy. I wrote in short, but it's better if you write it in details. Okay.
It will not make any problem in exam.
No, better. Okay. If you better write EK here. Final EK. Actually, the main EK is this one. That is why I'm trying to avoid it. Better you write like this. Okay. Kinetic energy. Full in details. Okay. Many times I will be writing something short, but you better write it in details. Okay. Because you don't know how the teacher who is going to cut check your paper, you don't know how he is. Okay, so he might be very sensitive about these things, so don't give any opportunity to the teacher to deduct your mark. Okay. Okay, now I guess we can solve one. Yes.
Sir,
Well,
for what we will use this equation?
that is what I'm trying to show you. Okay, next we are going to solve a numerical example. Okay, I'm going to solve a numerical example.
Fast.
So in the next page, we have an example. Okay. Let us see if you can discuss this one within 5 minutes. Okay. A force of, see, come to page number 104. There is a numerical example here. We are talking about this one. A force of 10 Newton is applied on a stationary object. Okay. So we will list the information given as we go through the question. The force, we know that is 10 Newton, right? And on a stationary object means the initial velocity is 0. It was at rest. Of object of mass 10 kg. The mass is given as 10 kg. For 10 seconds. Okay, the force. This force has been applied for 10 seconds. Okay. Then what is the kinetic energy of the body? Okay. As it was in rest, then we will use the kinetic energy equation half mv square. If you remember, okay, because it was initially at rest, so it will be half mv square. Now, if you check, we know the we know m, right, from here, but we do not know v. But if we want to, we can calculate v, right? How? You know v is equal to u plus at. Here, we have to calculate u. Initial velocity is 0 plus acceleration. Acceleration also we don't know. But to find out the acceleration, we can use f and m. Okay. Can I write f by m into t? Because f is equal to ma. Okay. From here, I can write a is equal to f by m. Okay. I can write this. So I will just replace the value now. F is 10 and mass is 10 into the time is 10. So it will be 10 by 10. 1 into 10 is 10 meter per second. Okay, so we have our velocity. Now we will just replace the value of v. It will be Ek is equal to half m d square, that is half into mass is 10 kg and velocity is also 10. So it will be 10 square. Okay, so 2 5, 10 square means 100. 100 into 5 is 500 joule. This is the kinetic energy of this body.
Sir, can't we write 0.5 kJ?
Yes, if you want to write it in kilojoule, you can write. You have to divide it by 1000. Okay, then it will become kilojoule. So 0.5 kilojoule. It's up to you. No problem. Acha. Any doubt, GM?
No.
Okay, now as you can see, there are B and C part also in this one. Let me check how much time we have. Okay, 2 minutes 30 seconds. I will try to discuss at least B with you now. Okay, see, in B said that calculate the kinetic energy after 20 seconds. Now this is kinetic energy after 10 seconds, right? But now we have been asked to find out the kinetic energy after 20 seconds. Now I can divide this 20 second into two parts. This is first 10 second, this is next 10 second, right? Now in the question it is mentioned that this force was applied for first 10 seconds. In the first 10 seconds there was a force. About the next 10 seconds they did not mention about any force, right? In the next 10 seconds, as they did not mention about any force, we will consider that no force was applied in this part. If there is no force means no acceleration, and no acceleration means no velocity change. Velocity means v change, no velocity change. As you can see in this part, velocity did not change. Now tell me one thing. We know that Ek is equal to half mv square. The mass of the body will not change unless we change the body itself. So we are not changing the body, the mass will not change. And we saw that in this next 10 seconds, the velocity is also not changing. If the velocity is also not changing, then Ek, will it change? It won't change.
No, EK will not change.
Ek will not change. So after 20 seconds, it will be the same kinetic energy because the mass did not change and velocity did not change. Kinetic energy depends on two factors, that is mass and velocity. So if mass and velocity, both of them are not changing, the kinetic energy will not change. See, it is written in your book in the solution B. Acceleration will take place for 10 seconds. That means for first 10 seconds, force is there. So acceleration will take place. After that, no acceleration is present, so velocity is unchanged. Therefore, kinetic energy after 20 seconds will be the same. That is, it will still be 500 joule. Okay, less than 1 minute. Anytime the meeting is going to be finished. Kindly go through the C part. Okay, I talked about A and B. Kindly go through C part and let me know if you have any doubt in the next class. Thank you for joining. Assalamu alaikum.